Hello everyone. Our goal in this video is to select a real data set and pre-process the data using Python. This includes data cleaning, data integration, data selection, data reduction, data transformation, and discretization. Then, we will use supervised learning and classification methods like separate vector machine, SVM, naive Bayes, K nearest neighbor, logistic regression, and decision trees. At the first, I will explain about the dataset. This dataset is about the PIMA dataset. The PIMA or PIMA Indian Diabetes dataset is a dataset that comes from a study on women of the PIMA Indian heritage in the United States. It is used in the medical field to see if we can predict the likelihood of diabetes based on various health features. So, as you see, the data set has 768 records and 8 features and 1 outcome. These features include things like the number of pregnancies, glucose level, blood pressure, skin thickness, insulin, BMI body mass index, and diabetes pedigree function and age, and finally about the column I you can see outcome. So first of all, I'm gonna talk about fields. Column A, pregnancy, the number of times the woman has been pregnant. More pregnancies can increase the risk of developing gestational diabetes, which is linked to type 2 diabetes. Glucose, this column B, this is the plasma glucose concentration measured 2 hours after an oral glucose tolerance test. Higher glucose levels are one of the strongest indicator of diabetes. Blood pressure. This is the diastolic blood pressure. High blood pressure is often associated with insulin resistance and diabetes complications. Skin thickness. This measures the thickness. It indirectly reflects body fat and can be related to obesity, which is a risk factor for diabetes. Insulin, this is the 2-hour serum insulin level. Abnormal insulin level can signal insulin resistance, a major cause of type 2 diabetes. So you can see column F, BMI, body mass index. BMI is calculated as weight in kilograms divided by height in meters squared. It shows whether a person is underweight, normal, overweight, or obese. Obesity strongly increases diabetes risk. So next column, column G, you can see diabetes pedigree function. This is a score that estimates the genetic influence of diabetes in the family. A higher value means a stronger family history and a higher likelihood of developing diabetes. And the other is age, the age of the patient in years. The risk of type 2 diabetes generally increase with age, especially after 30. And finally, outcome is very important, and we want to predict the diabetes or no diabetes. This is the target variable. Because of this reason, we say that classification. One means the person has diabetes, and zero means they do not. The goal of classification is to predict this value using the other eight features. So at now, I would like to talk about Google Colab because we want to write the program in Google Colab. What is the Google Colab? Google Colab or Google Collaboratory is a free cloud-based platform provided by Google that allows you to write and run Python code directly in your browser. In this video, we are using Google Colab because it offers several advantages. One, the first, you don't need to install any software or compiler on your computer. The second, it, it gives you access to Google's powerful computing resources. And finally, you can easily save, share, and collaboration on your project online. So at the first, you can type in Google Colab and register in Google Colab. And after making a new program such as this, I will start. At the first, the name is diabetes, for example, for me. Another things, go to runtime, change runtime type. You have CPU, TPU, GPU, and so on. And I use T for GPU, because I want to use Python, this is Python, and you can see Google Colab support Python 3, the R, and Julia. So after saving, I am ready to start. At the first, I want to import numpy as np, import pandas as pd, import matplotlib, you can see this is, and import cburn as sns. So for running, I use this. So at now, I would like to talk about what is NumPy, Pandas, Matplotlib, cburn, and what about the application of this. NumPy, we say import NumPy as np. NumPy is a powerful library in Python used for numerical computations and working with arrays and scientific computing. We import it as np. It means that so we can easily use its functions for mathematical operations throughout our project. So pandas, import pandas as pd. Pandas is a popular data analysis library that allows us to load, clean, and manipulate data sets efficiently. We import it as PD so we can work with data in table format using data frames, but today we use pandas for reading the CSV file, diabetes CSV file, Excel file. So next is matplotlib. It's very important. Matplotlib is a visualization library. If you remember, in SOAR analytics model, S specify the question, O obtain the data, A analyze the data, and R report the result and visualization. Matplotlib is a visualization library or for and very good for report the result. Helps us create plots, charts, graphs. We import the Python plot, PyPlot, we say that module as PLT to generate visualization for understanding patterns in our dataset. And Severn is a statistical visualization library. Makes it easier to create beautiful and informative charts. We import it as SNS to produce advanced visualization like, for example, heat maps and distribution with simple commands. So after running this block, this is the first block, I created the next block. At now I would like to read CSV file. So the name of the file is df. I will explain. PD I call pandas, and you can see read CSV. So as now I need to call my dataset CSV file. For reading the file, go to left, you can see this is files, click, go to this part, and please find your file and select your file. Depend to you. For example, in my computer I created a folder which is called diabetes, and I want to use this, but for you depend, you can use Google Drive and so on. For example, for me, diabetes, okay, and exactly I need to write the name is not capital, is a small, diabetes dot csv, exactly such as this, and I run this, and df.head. I will explain about this. So what is the meaning of this? At the first, this command df equal pandas pd.read csv. This command loads the diabetes.csv Excel file into Python using pandas. It creates a data frame which is called df, you see, which allows us to work with the dataset in a structured table-like format and so on. And the other command is df.head. This command displays the first five rows of dataset. It helps us quickly check that the data has loaded correctly and gives us an overview of what the dataset looks like. For example, if you use 10, you can see 10 records from the first. So we are ready for next block. So at now, before pre-processing of data, we need to understand about all of the columns. We use df.info I run this. Yes. So in info df.info, this command shows a summary of dataset, including the number of rows, columns, and the data type of each features. It also tells us how many missing values each column has, helping us understand the quality of data before pre-processing. Next is df.shape, is very clear and is important. After running, you can see we have 768 records and 9 features. If you remember, I mentioned 8 features and only one outcome, and is the finally we want to understand about the diabetes or no diabetes. Again, df.shape, this command returns the size of the dataset in the form of rows and columns. It helps us quickly see how many samples and features we are working with before starting the analysis. df.describe, I use this, describe. So if you remember, I mentioned before about the analytics. We have 4 analytics: descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics. So in descriptive analytics, we say that what did it happen in the past, what is it happening at now. So for descriptive analytics, we have several methods. For example, horizontal analysis, vertical analysis, ratio. For example, in Excel, you can use pivot table, and you can use plots such as scatter plot, histogram, bar chart, and so on. But one of the most important thing in descriptive analytics is descriptive statistic. In Python, for using descriptive statistic, you use df.describe, and you can see for 9 features, I mentioned 8 features and 1 output, we have count, mean, standard deviation, minimum, q1, q2, you can see q1, q2, q3, and max. So is it clear? For pregnancy, you can see we have 768. This is the average of the pregnancy. This is a standard deviation of pregnancy. This is minimum is 0. Q1 is 1, Q2 or median is 3, Q3 is 6, and maximum is 17. And for example, for glucose such as this, you can see. And one of the most, I think that I believe that one of the most important things and method for pre-processing of data, you can use descriptive statistic. For descriptive statistic, you can check all of the features such as pregnancy, glucose, blood pressure, and understanding about the noise, anomaly, outlier, and so on. Another command is describe. So I use .t is transpose, and you can see it's very clear. The rows is count, mean, and in columns we have pregnancy. And what happened, this transpose is the such as a matrix. You can see we interchange the columns and rows. And what happened in the rows, you can see the pregnancy, glucose, blood pressure. And how about the columns? Count, mean, standard deviation, minimum, Q1, Q2, Q3, and max. So how descriptive analytics helps detect anomalies? You know, one of the most important thing in business is finding anomaly, outliers, and noises. Descriptive analytics includes descriptive statistics such as this df.describe, helps you at the first identify abnormal values. For example, glucose is 0. This is impossible. And the other is detect outlier using minimum, minimum or maximum. You understand about the outlier. And notice noise or incorrect data, and understand data distribution before pre-processing is very important. So with descriptive statistics, we can see errors in our data and clean them before training or machine learning or deep learning model. So next step. In this part, I would like to understand about the how many diabetes we have. So I call df. So outcome. Sorry. Dot value. You can see value dot cons and run this. So so this command df outcome, this command counts how many people in the data set have diabetes, outcome is equal 1, and how many do not, outcome is equal 0. It helps us understand the class distribution, which is important because an unbalanced data set can affect the performance of machine learning models. So when we run df outcome dot value counts, it means that we usually see more people without diabetes 0 than with diabetes and is 1. This is this is called an imbalanced data set. Again, imbalanced data set, because one class has many more samples than the other. You can see 500 person 0, no diabetes, and 268 has diabetes. So the reason this imbalance exists that in real life most people do not have diabetes, so the data set naturally reflects the real population. However, imbalanced data can be a problem for machine learning and deep learning because models may learn to predict the majority class more often and ignore the minority class. So next, for example, for pregnancy, df about the pregnancy, I use this dot value counts and run this. So this command about the pregnancy counts how many women in the data set have each pregnancy number 0, 1, 2, and so on. It helps us understand the distribution of pregnancy and detect unusual or rare values that may affect the analysis. So Next is I want to explain this. So, so this part is important. Please pay attention. Uh, the command df is null dot sum checks the entire data set and counts how many missing or null values, non or null values exist in each column. This is a very important step in data preprocessing because missing data can cause errors, reduce model accuracy, or create bias in your result. By looking at the number of missing values in each feature, we can decide how to handle them. For example, whether to remove those rows, fill, fill them with the mean or median, or use more advanced imputation techniques. In many data sets, missing value are simply recorded as blank cells, but in medical data set like PIMA, now you can see, some missing values appear as zero, even though zero is not a realistic number. For example, zero glucose or zero blood pressure is not real. So checking for missing value is only the first step. Later, we must also check for incorrect or impossible values. Overall, df.isNull.sum helps us measure the quality of the data and prepare it properly before training or machine learning or deep learning models. Next is about the duplicate. Drop duplicates, open parenthesis and close. Yes. So about the drop duplicated, this command removes any duplicate rows from dataset. A duplicate row means that allow the values in that row are exactly the same as another row, which can happen due to data entry errors, maybe merging data sets or repeated measurements. Duplicate records are considered data noise because they do not add new information and can cause your model to learn bias patterns. For example, if the same patient's information appear multiple times, the machine learning model may overfit. I will explain about the meaning of overfit in future, or give too much importance to those repeated values. By removing duplicates, we make sure that each record in the dataset represents a unique sample. This step improves data quality, reduces redundancy, and helps the machine learning model learn more accurate and balanced patterns. So next is for visualization, and I want to use Severn, sns dot severn dot cont plot for this part. So this command creates a bar chart that shows how many people in the data set have diabetes. It means that outcomes equal 1. And how many do not? It means that outcome is equal 0. We are using Seburn's cont plot function, and by setting x equal outcome about the column outcome, we tell it to put the outcome value 0 and 1 on the x-axis. The height of each bar represents how many records belong to each class. It is important to note that the visualization is very useful because it helps us see the class imbalance in the data set. If you remember, I mentioned about the imbalance data set. Usually we have more non-diabetic cases than diabetic ones. Understanding this imbalance is important before training or machine learning or deep learning models because it can affect performance and evaluation. So another block, another example, for example about the pregnancy. We want to use box plot, cont plot, yes, dot about the pregnancy. So about the pregnancy SNS cont plot, this command creates a bar chart, you can see, that shows how many women in the dataset have each a specific number of pregnancies, 0, 1, 2, 3, and so on. The x-axis represent the number of pregnancy, and you can see the y-axis shows how many records fall into each category. This helps us understanding the distribution of the pregnancy feature and see which values are common and which are rare. It can also help us spot unusual or extreme values that may influence the diabetes risk or affect our model. So another things, if you remember, I mentioned in plot about the histogram, df.hist figure size, for example, equal 10 comma 10 is important. Yes, I run this. Yes, you can see. So this command creates histograms for all numerical columns in the dataset at the same time. Please pay attention. I mentioned data can be divided categorical and numerical, and you can see all of the data are numerical. Each histogram shows how the values of a feature are distributed. For example, you can see about the pregnancy, about the glucose, blood pressure, BMI, insulin, skin thickness, and so on. Histograms are very useful in data preprocessing because they help us virtually detect outlier, skewed distribution, noise, and unusual pattern before applying machine learning or deep learning models. So another thing is very important is correlation. I want to explain about correlation. So at the first about the command, correlation matrix is the name, equal df dot correlation, and this is correlation matrix. You can see this is the result. So about the correlation matrix, this command calculates the correlation matrix of dataset. You know, correlation shows how strongly two variables are related to each other, and value ranging from -1 to +1. A positive value means both feature increase together, and a negative value means when one increase the other decrease, and is when is near to 0 or 0, no relationship. Is it clear? And another thing about the core matrix, what is the meaning of this? When we display core matrix is the name, we get a full table showing the correlation values between every pair of features. This helps us understanding which variables may be important for predicting diabetics. For example, glucose or BMI might have a higher correlation with the outcome. Correlation analysis it is important to note that is a key part of preprocessing because it helps us identify one, the first, a strong relationship between features and variables, redundant features, patterns in the data that improve model performance. So next block, uh, again about the correlation matrix. Yes, this is correlation core matrix outcome dot sort values ascending false. At the first I run this, and what happened? I will explain what happened. So this command select the correlation values between every feature and outcome column from the correlation matrix. Then it sorts this value from highest to lowest, so we can easily see which features have the strongest relationship with diabetes. Sorting the correlation helps us quickly identifying the most important predictors. For example, features like glucose or BMI may show higher positive correlation with diabetes. This information is very useful in machine learning and deep learning because it helps us understand which variables may contribute most to the prediction model. It is also allows us to detect weak or irrelevant features that may not add value during training. So in the next in regression and classification, so this problem is classification, we want to understand about the relationship between x and y. It means that we want to find functions such as f of x equal y. Because of these, at the first I prepare x and y. X is the x1 from x1 to x8, and y is outcome. So what happened? My data frame is df dot drop outcome o is capital outcome and exists equal 1. Another y, a small y, x is capital, df outcome, and for understanding and clarification x and y, run this, what happened? You can see. Yes, I explained about this command. So At the first x equal df data frame dot drop, what is the meaning of this command? This command creates a new dataset x that contains all the input features I mentioned from x1 to x8, pregnancy, glucose, BMI, and so on until age, except the outcome column. You need to delete outcome from your dataset. We remove the outcome column because it is the label, and we want to predict this, not a feature we use as input. We want to predict outcome. So why we say that in the next command, y is df outcome? This command creates the variable y, which contains only the outcome column. This represents the target variable. The value may be 0 or 1, I mentioned before, that or machine learning model we learn to predict. And finally, you can see this is x and y. This displays both x and y, so we can visually check that the split was done correctly. X now contains 8 columns, 8 features, 8 attributes, variables, dimension, and so on, and y contains 1 column, the class label. So in other things, I want to use data structure array, and I want to call numpy. For this, x equal np, I call np dot array. I will explain. So this is x, and y equal np dot array y. Sorry. Type x and y and run this. You can see this is the array. This data structure is very clear, and I want to explain about this. So the first command, this command converts the data frame x, which contains all the input features you remember from x1 to x8, into a numpy array. Machine learning and deep learning algorithms often work faster and more efficiently when the data is in numpy array format instead of a pandas data frame. And the next command is about the y. This converts exactly similarly the target variable y, the outcome column, into a numpy array as well. By converting both x and y to arrays, we prepare the data in a format that is commonly used for training machine learning or deep learning models. So another command x and y, it means that this displays both arrays, so we can visually confirm that the conversion worked correctly. X now appears as a two-dimensional numpy array features, and y appears as a one-dimensional array. Is it clear and very obvious? So this is array x and y. You can say this is x and this is the y. So another things is about the pre-processing of data, is about the data transformation. So at now I want to call scikit-learn dot. So I need to use pre-processing data, pre-processing, and I call a standard scalar, and a scalar is a standard scalar. X is a scalar dot fit transform, and x. What happened? I will explain about this at the first run. You can see data, but at now discuss about this block. So from scikit-learn pre-processing import a standard scalar. This line imports the standard scalar tool from scikit-learn. A standard scalar is used to scale or normalize the data so that all features have a similar range, which helps many machine learning or deep learning models perform better. And another comment you can see scalar equal a standard scalar. It means that we create an object called a scalar from the standard scalar class. This object will be used to learn the scaling parameters, for example, mean and standard deviation, from our data. And finally, x equal scalar dot fit transform x and x. It means that this command first fits the scalar to the data, meaning it's calculate the mean and standard variation for each feature. Then it transforms the data by scaling each features so that it has a mean of 0 and a standard deviation of 1. And it is important to note that nearly, not all of the data, nearly all of the data are between -3 and 3. 99.70% of data between -3 and 3. So scaling, please pay attention. Scaling, it is important to note that scaling is important because many algorithms, for example, support vector machine, decision tree, logistic regression, k nearest neighbor, perform much better and converge faster when the features are on the same scale. Is it clear? So at now we use uh, pre-processing of data. I mentioned that the pre-processing of data consists of data cleaning, data integration, data reduction, data selection, data, and finally data transformation. You can see in this file and in this example, especially I use data cleaning and data transformation. And at now, I think that your data set is ready for using and finding model. So this method for classification, if you remember in machine learning can be divided supervised, unsupervised, semi-supervised, and reinforcement learning. In supervised learning, we have a label, and we have data set and a split data set into train and test. Is it clear? So, and we have label. So for this part, because I want to use supervise and I want to use classification before using methods such as support vector machine, I need to split data set into train and test. So for this, from scikit-learn model selection import train and train test split, you can see I call scikit-learn model selection import train test split, and x train because this reason your data set can be divided train and test, and you have X and Y. So X for train, X for test, Y for train, Y for test. So equal train test split, you can see. So X, Y, comma, the test size, I will explain. It means that 0.20, 20% is about the test, and 80% is about the devoted to train. And random, please type random state equal 42, and type X train, X test, Y train, and Y test. So this part is important, please pay attention. I mentioned about the from scikit-learn.model selection, import, train, and test. At the first, about this command. This line imports the train test split function from scikit-learn. It is used to divide your dataset into training and testing parts. So for this line, what happened? This line. So X train, X test, Y train, Y test equal train test split. You can see this command splits your data into 4 parts. X underline train, it means that 80% of the features for training. X underline test, it means that 20% of the features for testing. And Y underline train, it means that 80% of the labels or outcome for training. And Y test, Y underline test, it means that 20% of the labels for testing. The parameter test size equals 0.2 mean we use 20% of the data for testing and 80% for training. Generally, we use 20% for test, 80% for train, or 30% about the test and 70% about train. The parameter random state equal 42. What is the meaning of this? Ensures the split is always the same every time you run the code. This helps with reproducibility of this. Why we do this? We train the model on X train and Y train and then test it X test and Y test to see how well it performs on new unseen data. This helps prevent overfitting, and I will explain about overfitting, and gives us a realistic evaluation of model accuracy. So finally we have X train, X test, Y train, and Y test. It means that this simple this displays all 4 outputs, so we can confirm the split work correctly. So, and you can see this is after running of this. Is it clear? So after this, I want to know about the dimension of this X train and X is capital train dot shape
xtest.shape, ytrain.shape, and ytest.shape. So this line, this command displays the size, rows, and columns of each dataset after the train test split. For example, xtrain.shape, it means that shows how many training samples and features are used to train the model. And how about the xtest.shape shows how many samples are reserved for testing. ytrain.shape and ytest.shape shows the number of training and testing levels. This is an important step because it helps us confirm that the data was split correctly. For example, 80% of rows should be in the training set and 20% in the test set. It also ensures that the number of feature rows matches the number of label rows in both training and test dataset, which is required before we fit a machine learning model. So this is the end of the first part. This is the pre-processing of data. Again, I use a library such as NumPy, Pandas, Matplotlib, Seaborn, and next I read the data set and I use the head for understanding the records, for understanding the property of features and information about this. I use df.info, and after this I use df shape. I understand about the how many records and columns we have. Fine. After this I use descriptive statistic, df.descriptive statistic. I understand about the number, about the, for example, in this part I understood about the imbalance data. We have imbalance data about the histogram and about the distribution of the data of pregnancy and about the missing value in data cleaning and dropping duplicate in data cleaning again, and use visualization for understanding anomaly, noise, and distribution of data. We use Seaborn and box plot. We use cont plot in Python, and so on for pregnancy, and using histogram for understanding distribution of data. After distribution of data, about the correlation, I use correlation, and I mentioned before correlation is between -1 and 1. Near to 1 strongly positive relationship, -1 strongly negative relationship, and 0 no relationship. And about the again at now I need to prepare my data set X and Y because I want to use correlation or regression in this, sorry, classification or regression. In this part I want to use classification. For classification we want to know about the X and Y. We want to find F. Because of this, X is X1 to X, from X1 on to X8, and Y is outcome. And I use array, is very good and powerful data structure in Python, and because of this I use numpy.array. And if you remember, I mentioned data cleaning, data integration, data reduction, data selection, and data transformation. In data transformation, I need to rescale all of the data. We have some methods for uh, data transformation. One of the most important is a standard scaler. I mentioned that nearly 99.7% of data after using a standard scaler are belong to -3 and 3. And after this is very important, this part I prepare my data set, and I split my data set into train and test, and 80% train and 20% about the test. At now, my data set is ready for classification. In the next session, I will try to use support vector machine, k nearest neighbor, decision tree, random forest, multi-layer perceptron, logistic regression for calculating and classification diabetes. Thank you so much. See you in next video. Bye.